Hi, welcome to week 2 of Algebra 1 SOL Prep. Today we're going to be reviewing box and whisker plots. Here's a basic box and whisker plot, and recall that a box and whisker plot represents a data set, a list of numbers. It's just a drawing made to represent a list of numbers because it's usually easier to understand a drawing than to understand a list of numbers. Important parts that you should remember of a box and whisker plot are these vertical lines, part of the drawing. There are important locations. They mark important information about your data set. The first important part that we're going to be looking at is this middle line right here inside the box. That is called the median of the data set. The numbers marked here at the end of the box and whisker plot drawing, not at the end of the number line, the end of the box and whisker plot drawing, that is going to be the lower extreme or the minimum, and then the upper end, the right hand side end of your drawing, that's going to be called the upper extreme. The limits of the box itself, from right end to left end of the box, those also have special names. This is the lower quartile, or Q1, and this part is the upper quartile, or Q3. The range of the data can easily be found by subtracting the maximum minus the minimum, since this value represents the largest value in the data set and this value will represent the lowest value in your data set. Another important range for the box and whisker plot is the interquartile range. It is a range, but only for the box section. So it's going to be the highest quartile, Q3, minus the lowest quartile, Q1. That is the interquartile range. When they ask you what percent of the data falls between each one of these sections, remember that each different part of the box and whisker plot, like I have highlighted in different colors here, will represent 25% of the data. No matter whether the section is short or very long, each part will always represent 25% of the data. So if they ask you what percent of the data lies between values of, say, 5 and 12, you would look for the 5 right here. You would look for the 12 right here, and you see that that includes 2 sections of the drawing, so that would be 2 of those 25%, so that would be 50% of the data between these two numbers. If they ask you how many data points were used between, say, the same 5 and 12, you would need to go back and look up in the instructions part of the problem. Somewhere along the instructions, information will be given about the total number of data points used to create that particular box and whisker plots. Let's say that for this particular example, 100 data points were used. You will need to remember that each section of the drawing represents that total divided by 4. And divide the total into 4 equal parts. So for this particular example, each part will represent 25 data points. 100 divided by 4 is 25. And so the number, how many data points between 5 and 12 would be, between 5 and 12, that's 25 2 times, so that would be 50 data points. So when you get a box and whisker plot, it might be very useful for you, before you even start the problem, to write the 25% under each section of the box and whisker plot, and on top of each section of the box and whisker plot, look for that total divided by 4 and write that number there. Then all the other questions can be easily answered. Let's move on to an example. First, let's review how to create a box and whisker plot if a given data set, like for example this one, is given. It's the same steps for stat that we did in the first review video. We go to stat and you press 1, and in that list, L1, you're going to enter your given list of numbers where they ask you to draw a box and whisker plot. And after you've entered all the numbers, you're going to double check that the numbers you entered match exactly with your list, that you didn't accidentally leave a number out. Then you're going to press stat, move over 1, and then the number 1 again. So let's do that. Stat, Move over to Calc, press 1, enter, enter, enter. The instructions are they're going to say to scroll down to the end of the list of values to find the minimum, in other words, the lower extreme, the Q1, the lower quartile, the median, the Q3, which is the upper quartile, and the max, which is the upper extreme. And with those numbers, draw your box and whisker plot. So let's scroll down. The values are 8, 10, 11.5, 13, and 14. So you draw a number line that includes those values. Then with vertical lines floating on top of the number line, you're going to mark your 5 positions. 8, 10, 11.5, 13, and 14. And with the middle 3 lines, you create your box, and then with the last outer lines, you create your whiskers. Let's look at another example. The box and whisker plots below summarize the data on credit hours taken by students per semester at 2 different colleges. The data was created sampling 440 students from College A, so this is a total number of points for College A, and 375 students from College B. So this is the total data points for College B. And let's color code. College B is in blue, College A is in red. Let's see. Which college used a data set that includes this set of data points? Well, you're going to focus on the smallest and largest numbers that you see in this data set. I can see here that this 3 is the minimum value of the entire data set. Which one of these 2 includes a 3 as their minimum? That would be College B. College A starts at 5. So College B would be the answer for this problem. Problem B, what is the median student credit hours for College B? Remember that median in College B, that's the blue one here, is the line inside the box. The value here is 13. Next, what is the range of students for College A? Recall that range is this one, the biggest value minus the smallest value. So for College A, which would be the top box and whisker plot, the largest value going down is a 21, and the smallest value is a 5. So you would subtract those 2 values, and you would get 16 as your answer. Next, what is the difference in interquartile range between both colleges? Keep in mind that interquartile range is now this value. It's subtracting only the ends of the box, biggest minus smallest. So I find the interquartile range for College B, which would be 16 minus 6, and I write it down here in parentheses, 16 minus 6. And then they're asking me for the difference, which we need to remember that difference means subtract. So the interquartile range for College B, I'm going to be subtracting the interquartile range for College A, which would be this value here, 16 minus, other end of the box here, 9. So that I write in parentheses here, 16 minus 9. If I simplify each parenthesis, I'm going to get 10 minus 7, which produces my final answer of 3. So remember, a difference in interquartile range means you need to find the interquartile range for each one and then subtract those 2 numbers. Next, approximately what percent of students from College A take 9 credit hours or more per semester? Well, let's go to College A and let's find that value of 9 right here. And they're asking us 9 credit hours or more. More means positive to the right. So 9 And if you need to temporarily draw a dotted line, you may. 9 or more. Recall that each section of the drawing is 25%, so including all of those percents to the right of the 9 would be 75%. Part F. Approximately what percent of students in College B take between 6 and 16 credit hours per semester? Between means going from 6 all the way to 16. So let's find in College B, which is the blue one in the bottom, the 6 is right here, and the 16 is right here. Recalling again that each section of the drawing is 25% of the data. Between 6 and 16, there's two of those 25%. So what percent are between those? 50%. Part G. How many students in this study reported taking 16 credit hours per semester or less? Or less means smaller, to the lower numbers to the left. Now, important parts of this part G. How many? It does not refer to the percent. It refers to the total, which, if you recall from the beginning, we write above here on the top of the drawing. By finding the total numbers for each one and dividing each one by 4. Another important part of this is that they talk about how many students in this study, not distinguishing whether they're talking about College A or College B. So they're really talking about all of them, all students in College A and College B. So we're going to have to be analyzing both box and whisker plots. Let's start by finding the total for each section of each drawing for College A and College B. For College A, if you recall, the total is 440, so if you take that 440 and divide it into 4 equal parts, you're going to get 110. So each one of these sections is 110 data points. You would do the same for College B. The total of students, data points used for College B, or underlined at the beginning, is 376. So you take that number, 376, and divide it by 4, and you get 94. So each one of these sections are going to be 94 data points. I'm going to erase the percent part because I don't need that for this part of the problem, and I don't want you to get confused about that. How many students reported taking 16 credit hours per semester or less? Well, you find the mark for 16 in each one of these box and whisker plots. So here's for College A, that or less. And for College B would be 16 again or less. And you're going to have to add up all of these 94s plus all of these 110s, and that would be your total students taking 16 or less. Adding all those numbers, your answer would be 612 students. The last part. Is the difference between the college's lower quartiles less, in other words smaller than, the difference between their lower extremes? Well, first, let's find what the difference between the college's lower quartiles is. Recalling that difference means subtract, I'm going to find the lower quartiles for each one. Lower quartile for College A is here at 9, and the lower quartile for College B is here at 6. And I'm going to subtract those two numbers. 9 minus 6, which produces a 3. Then they want to know the difference between their lower extremes. Again, difference means subtract. So their lower extremes are the very lowest value in the drawing. So for College A, the lowest extreme is here at 5. And for College B, the lowest extreme here is at a 3. So we're going to subtract those values. 5 minus 3, and you get a 2. What they're asking you is this 3 less than this 2? Well, no. 3 is not less than 2. So the answer here is no. This review should have you all prepped to work on the practice problems that you have in your worksheet, but if you get confused at some point, just come back to this video and watch these again to clarify any questions. Thanks for watching.